Mr. Stuart McClure.
Guten Tag. Guten Tag. Thank you so much for coming by and checking us out. So CYLANCE, in a nutshell, uses artificial intelligence to prevent cyber attacks on the endpoint, and we do so with true prevention and without any use of signatures. So most of the security industry, well, all of the security industry uses what we call signatures. So you have to know how an attacker works before you can prevent it. Well, we can prevent a cyber attacks even though we've never seen them before. We've never heard of this attack before, but we can prevent it, and I'll explain how we do all that. So like I said, we make software that predicts and then blocks cyber attacks on the endpoint, and we do it in real time, in pre-execution, before anything ever starts, and using pure artificial intelligence algorithms. So you can see every security vendor out here and in every other conference in the world, and they all do basically the same thing. They take an example of something that is bad or something you don't want to have run in your environment. They create a signature for it, and then they get that into the product as fast as possible. And they hope to create a very quick and short life cycle of that process. Well, we don't need that at all. We don't need to build a single signature to prevent completely unknown code from running on the computer. So I'm going to explain how that works and how we came up with the idea. So our mission is to protect every computer, user, and thing under the sun from cyber attack, because you can attack the computer, the person, or the device. You see a lot of connected IoT devices as well that have little to no cybersecurity intelligence. And we're really, really passionate about that model, that mission, is to prevent, truly prevent the cyber attack. So you've seen a lot of studies out there and a lot of annual reports. Well, Verizon does one every year called the DBIR. And what they do is they take all the cases of their customers and how they've been attacked, and they break it down for you in the report. So for the entire year of 2016, malware was used in about 90% of all these cyber incidents. And the other remainder used things like identity-based attacks. That would be stealing your username and password and logging in as you, okay? And then doing bad things. Well, of course, a lot of people are falling victims to the same old stuff, and nothing ever seems to be changing. So you get an email, not you, of course, in the audience, but users get an email, click on something like a link, or open something in an attachment, or plug something into a USB drive, and boom, you can have bad things start to run. And that is the infinite loop, is that what happens in our industry is once something gets created, a virus or a Trojan or a persistent threat like an APT, then all it has to do is change just very slightly, just change the body of that particular exploit or virus, and it makes it invisible to 99% of all security vendors out there in the world. And it's so trivial to do that the bad guys have mastered it in an automated system that continually checks with every single new variant whether or not antivirus or other technologies are going to catch it. And so it's really easy, which of course turns into constant incident response. And what we feel like as security professionals, right, is you feel like a firefighter where you didn't start the fire, but you're asked to stop it. And you're usually asked to stop it after it's a raging inferno with a garden hose, right? just desperately trying to get that fire out. When all along, you could actually prevent the first flicker of a spark. And that's the frustrating part, as you start to realize that you can apply AI into this problem set, and you still see folks that haven't adopted it yet. All right, so the state of our world today, I'm going to talk about it, and then I'm going to explain exactly how we work and what we do, how we do what we do. But really what we call is this 9-box of controls and process. So if you look on the left-hand side, you'll see the respond, the detect, and the prevent. This is the different ways to manage the security events that you see in your environment. You can either just wait until the bad guy gets in and respond. You can wait until the bad guy gets in and just detect and not actually do anything. Or you can actually prevent the attack. The simple analogy is, at your home, you could wait for the burglar to come into your house and go into your bedroom and look in the jewelry box and then catch them as they're in the jewelry box, or wait until they leave and then get the clues to figure out how did they get into the jewelry box and into the house and then respond. Or you could just prevent the burglar from ever getting into the house. Now, I know a lot of you like the fun of the chase, you know, trying to find the bad guy. And I get that. That's fun. I get it. But you can prevent 99.9% of all the bad guys getting in. Focus on the 0.1% that is really hard, really challenging, and it's going to test your wits. Focus all of your energy on finding that bad guy that's going to get past technology like AI. And then on the bottom, you can see the level of response that's often employed in companies. Everything from fully automated systems, semi-automated, to manual. Now, most everybody lives in that world, the manual world, in total response. They're just waiting to catch the bad guy doing something bad, and then trying to kick them out and figure out what was taken out of the organization. Too late. We have to start driving down to this automated prevention model. And if we can do this, this is the Holy Grail. So that's what I want to talk about. So how all this has come about is really starting from the antivirus world. Now, antivirus is all about signatures. And it was fine when you got like one virus a month coming out. But we have over 400,000 viruses and cyber attacks every single day coming out. That's just the ones we see, by the way. I mean, there's probably a good 10%, 20% we never even see. Well, the reason why the signatures approach, really detect and respond, hasn't worked is because the bad guys are too fast. It's too easy to mutate this stuff and get back in. So what a lot of vendors have done is created these sort of, what I call them, symptom prevention or management. Things like host intrusion prevention systems, sandboxing solutions, isolation, even EDR, which is enterprise detect and respond, which is really just, again, responding to a breach that you detect earlier. But ultimately, all of that is still signature-based, okay? So AI is really, in our space, the first time really being applied into cybersecurity in the last couple of years. And really, nobody we've seen so far has done it to the degree that we have. So let me explain what we do and what we don't do. Sometimes it's easier to describe who you are by saying who you're not, right? Well, we don't depend on human beings for classifications. We don't require an on-premise infrastructure. We don't wait for threats to execute and then try and catch it with signatures. We don't have constant updates. Our math model's updated once, maybe twice a year, and that's it. So about every 6 to 9 months. No signatures, so no daily updates, no weekly, no monthly, no nothing if you don't want. No heuristics, which is just signature-based, no behavioral, no sandboxing, no micro-registration, and no dependence on the cloud. So we don't need the cloud to get better protection. All the protection is right on the computer. So you don't need to go out to get better protection. So what we've done is basically we kill we break the kill chain because we never allow it to start. Never allow it to load into memory, pull from the file system, and execute in any way, shape, or form. We really have discovered the DNA of cyber attack, okay? So some of the details on the technology itself, of course, we are a full-blown AV replacement, so about half of our customers now completely replace traditional antivirus. The other half can't wait to replace traditional antivirus. And they're waiting until their subscription runs out to do that replacement. So we do work alongside other antivirus as well, but very small footprint, 1 to 2% CPU, 40 to 50 megs in memory. And we run on just about every variant of Windows, even those that are end of life, like Windows XP. So typical deployments and how it works is quite simple. You get the technology deployed to as many computers as humanly possible, as fast as possible, and you have it in alert-only mode. Now, usually within a day or two, it starts to find all kinds of crazy stuff. Things that you never really thought possible, given the technologies that you had. So then you start to realize, I've got to start to prevent this stuff. So you start to add in more and more controls into your policies until eventually you get to zero threats. Zero threats present in the environment. And then you flip the switch to do full prevention mode. We have over 90% of all of our endpoints are in this state today with our customers. We have about 4.2 million endpoints protected with CYLANCE today. So, what's the secret, right? There is secret sauce here. I'm going to try and explain it as best I can without giving away everything, in case, you know, there's others that want to try and do better than us, which who knows, maybe you will someday. But we've unlocked basically the DNA of malware, all right? So this is how it works. So machine learning works very simply. It is actually quite simple. And there's only two forms of AI, by the way, just in case, you know, you don't get confused. There's general AI, which is really learning in a broad data set, like it's unlimited data set. You're basically trying to train algorithms to self-learn, okay, unsupervised. Then there's narrow AI, which is really, okay, we give it a very controlled data set, and it learns amazingly well from that controlled data set. So we use narrow AI technology. So we collect as large amount of files as we possibly can. Executables, DLLs, PDF, Office docs, scripts, you name it. Okay, we have about 1 billion files total, about half that are good and half that are bad. Then you extract as many features as you possibly can out of that. Now, what are features? Features can be the size of the file. Now, is that a very predictable variable and feature? Probably not. That'd be saying like, well, I can tell how many women there are in this audience by the length of their hair. Yeah, I mean, I'd probably get close, but like I'm going to have a high false positive rate, right? So that's not a great feature. You can't use one feature, right? Another one might be, okay, what permissions are there on the sections inside the binary, okay? And so both may be combined. File size with these features or the permissions on these data sections might be a good one. But that might also lead to, well, I can tell the men and the women in the crowd here by the amount of facial hair. Now again, I might get pretty accurate with length of hair and facial hair in determining the two, but I'm going to make some very embarrassing errors too in that process, right? And I don't want to do that. So as you can see, more and more and more features start to create separation between two groups of good and groups of bad in our system. So once we're able to actually collect all of these features, now we're almost 3 million features that are mappable. And by the way, I get a lot of questions around what's the total potential size of features for files in cybersecurity? Well, actually, we've done the math on it. And to draw an analogy, I can't actually remember the number, it's so large, but if you draw an analogy, if every atom in the universe, in the known universe, right, we have to get clarity, if every atom in the known universe had its own universe of atoms, there still would be more features in a file that we could map to. So the space is huge. So 3 million might sound like a lot. It's actually a very small number, okay? But it's enough to get us true distinction between good and bad at a 99.99% accuracy rate. So we transform and vectorize and train based on that data. We train using neural networks, real simple. And then that creates a classification of good or bad, and then a determination so that we can prevent in real time. And we cluster based on that. Now this, so sorry, go back to this. This is it. This is the secret sauce. This is what the whole company's been created on, and this is what the tech does. And it does it so darn well that I say instantly, I'm like, don't trust me for a second. Like, don't even listen to me when I say that this stuff works. Just test it for yourself. Go to our booth. They'll do a nice, fun, live demo for you. Find somebody in green, usually easy to find, and they'll do a live demonstration of downloading real malware, viruses, etc., that are just published today out in the wild, mutate it, and we'll try and run it on us and other people and see how it goes. But ultimately, test for yourself. That's what we recommend. Don't trust anybody. So the management console is in the web, or in the cloud, so you can log in from anywhere. You can integrate just about any other technology, so we feed through syslog into other SIM platforms. We do things like application control. We can give you evidence as to why we think we called it bad. Now, we can't explain why we called something bad. That's really important. And I'll give you the secret question to ask any vendor if you want to know if they use signatures, okay? You just ask them this one simple question. When you detect that this is bad, why do you call it bad? And if they can explain, well, it loaded into memory in this place, and then it overwrote the EP in this spot, and then it went and tried to delete this file, and tried to encrypt this file, and then it did this, that is actually a signature. That's the definition of a signature. So we can't explain to you why we convict on it. We just, literally the math convicts on it statistically that it is bad. So, but we'll give you some indications as to why we think the math called it bad. All right, just a simple little video. You've probably seen a ton of ransomware. If you haven't already in your own environment, you've seen it probably live. In this particular one with Petya, it actually encrypted the MFT itself, the whole hard drive. So right from sector 0. It was a nice one, a little nasty one, right? And it was distributed using a PDF icon. So if you got an email with an attachment and it had a PDF reader icon on it, a lot of users are going to double click because they think, oh, this is just a PDF. It can't be all that bad, when it really is an executable. And it was able to get on a ton of systems, hundreds of thousands of systems around the world. So that's a fun one. Of course, cybercrime, you hear about it all the time, but the numbers are incredible. That's why there will always, as long as there is money to be made in this industry, the bad guys will continue to go after it. And when we started the company CYLANCE back in 2012, we knew that there was no way we could stop all of hacking. That's just not possible. But we wanted to make it super, super, uber hard. And we wanted all those young little budding hackers that are doing it for bad to find other forms of employment, like a Taco Bell in, whatever country, or a KFC, or something, anything, okay? But just not cybercrime and hacking. And that's what the technology does today. So you can take just about every single vector of attack that goes into a computer system. For example, there's an email document with malicious macros that comes and grabs malware off the web. We block against that. User downloads malware directly from a link. We block that. A document with PowerShell fetches codes to dump credentials so they can do lateral movement. Block that. I can go through it on and on and on. It exploits a browser, no problem. Why? Because all of these things have to execute in memory. And that's where we sit. We sit looking at every single attempt to execute something in memory, and we evaluate it statistically and mathematically and determine whether it aligns more to good or to bad. And all of that is done in less than 100 milliseconds. So, blink of an eye, couple blinks. No signatures, like I said before, no internet is required. It finds even potentially unwanted programs, things like PS-exec and other tools that are used for lateral movement. We also have real-time memory protection for in-memory exploitation. So if you click on a link and it actually tries to exploit a browser vulnerability in IE or in Chrome or in Safari, we can block that as well. Process injection. We have script control capabilities, being able to prevent PowerShell scripts or VB scripts, JavaScripts, JScripts, all the forms of attack that the bad guys try to pull together, or what's often called fileless attacks. Then we also have the ability to actually control everything on the computer with application control. What happens there is we scan the system, tell you that it's safe and clean, then you turn on this application control, and now nothing outside of that environment can ever execute. So if you plug in a USB or you try to execute something through a browser or through email, it just never allows it to run. So we are a cloud-based architecture. We have our data store in the cloud as well as our management in the cloud, but our protection is on the endpoint, and you do not need to be connected to the cloud to get protection. All of it is encompassed inside of the computer itself. So we have customers that are, in submarines for 6 months and they don't come up for air, much less a virus signature update, right? They're protected. You'd be amazed at how many offline scenarios are really important to stay protected on. All right, so with that, I know I've got a few minutes of time. Any quick questions of me? Yeah. Yes. Right. Yeah, that's a good question. So I'll repeat the question because I could barely hear it. You probably did. Yeah. In asking about the application control feature of the product, he asked, is that it just locks down the whole box so nothing else can sort of run that's not already on the system? Yes, that's true. And that's why normal users wouldn't use that function. Where you'd use that is on point of sale systems for retail, or an ATM for a bank, or an industrial control system, a SCADA system. Things that never change, that should never change. They're fixed function. They're there for one reason and one reason only. So a lot of our industrial control systems customers use it on their systems. Yeah, no, it's offline. Yeah, you can. So the question is, does it require the internet to do that or not? And no, it does not require the internet in any way. It runs and controls everything on the endpoint without connectivity to the cloud. I know we had another question here. Yeah.
So why is the management interface on the cloud? Can't you have a version that's on the private cloud for regulation?
So we do get some, yes, and especially here in Germany, we always get that question. Now, the good news is the cloud architecture is in Germany, so we use AWS Germany.
We come from the Middle East, so...
Yes, so Middle East. Well, we could stand up a Middle East shard, etc. There are a lot of places we can stand up the cloud infrastructure. However, this summer, we have an on-premise solution that's going to be coming out in July for any companies that are 10,000 or smaller, so 10,000 employees or computers or less. Later in the year, because we have very, very large customers in the millions that want an on-premise, we're going to be releasing an on-premise solution at the end of the year that'll help them.
What's the exact role of the cloud management software? So what does it do?
It allows us to scale, number one, really, really fast. We can spin up thousands of computers in a split second. It allows us to control and maintain the proper versioning, and we can fix things really fast. If there's a bug in the management console, we can fix it on one and it can be fixed for everybody. On an on-premise, you have to provide the fix. You have to take the disk, right, move it over, hit OK, install, and there's that gap. That support window costs us money, lots of money. So we've always been really shy to do that.
Last question, does it run with admin rights?
Right.
And how do you prevent tampering?
Yes. So does it run with admin rights, and how do you prevent tampering? Yes, it runs with admin rights, but we have put so much effort into self-protection. I challenge you to try and stop it. Try and uninstall it. Try to kill it. Try to do something.
In safe mode?
In safe mode? You mean like, does it run in safe mode?
Yeah, exactly. In Windows safe mode, can you uninstall it, or does it run? Or
you can, but you'd have to be physically at it, and you'd have to have the admin creds, you know, stuff like that. But you could try and let us know. You know, we're always up for a challenge. We're not perfect, right? There's always a way around it. So if you find a way, let us know, because we're working on each and every one of them.
Okay. Would you retain classical antivirus on the same endpoint?
You could retain classic antivirus on the same endpoint, but all of our customers, and we have over 3,000 customers today, desperately want to remove antivirus because the performance overhead on the computer is horrible. The performance overhead on the network in terms of just data bandwidth usage is horrible. We get rid of all that. It's just a tiny little footprint, you know, very little CPU, very little memory, like basically no network traffic. People have bought our technology simply because we remove the network traffic. It's funny. Yeah.
You know, I guess that this kind of solution, I mean, has much more false positive than classical antivirus. I mean, just because
actually,
for the way it works.
You think that, but it doesn't actually. So so I used to be global CTO, Chief Technology Officer, for a Tier 1 AV company, okay? You can look me up on my LinkedIn or whatever. I'm not going to disparage anybody, because the whole industry is like this. It's a major problem. But I'm telling you that the accepted false positive rate of a Tier 1 AV, at least when I was running the ship, was a 0.002%, okay? We regularly measure with all of our customers 0.0001. We're lower than the industry average for accepted false positive rate. And it's a common myth though, and a lot of people think that, but we've been able to get the AI to such a degree that it's at the 99.9 and the 0.0001 now. Now, in the beginning, our first math model, absolutely. It was 60% and 10% false positive rate. And we were like, uh-oh, like maybe this is not going to work out. But you have to remember, we got to 60% effective in a world that's 30% with 7 people instead of 2,000. I had 2,000 people at my past company that wrote signatures all day long. 7 people. So now we're at the 99.9. and the 0.0001. And it's just because it iterates through and learns and gets smarter every single time. So if it misses something, we feed that back in, reclassify it to the bad or the good, whatever we missed on, and it gets smarter. You get the new model, and it improves. Now we're gotten so good, that's why we don't need models but every 6, 9, 12 months. And we constantly, when a new attack comes out, we will actually compare to prior models last year, the year before, and they still catch it even though it just was released today. So I know I got to head off. Thank you so much. We're over there at the booth if you want to come see and get a demo. Thank you.
Stuart McClure von CYLANCE. Vielen Dank.